Solving linear trigonometric equations. So here's example number 1. You're asked to solve the following, where theta is between 0 and 2 pi, and you're to evaluate it correct to 1 decimal place. So what the goal is to solve for theta. Now, if we see tan theta here, what we're trying to do is solve for this tan theta first, and then we can get rid of the tan by doing tan inverse. In order to do that, what do you think we need to do first? Well, hopefully you're thinking that we should take this 3 and move it over. And you're exactly right. So it should be, when you do it, you divide by 3, and then you move over the plus 1 to the other side, and you have 2/3 minus 1, which gives us negative 1/3. So now you're to do the tan inverse of negative 1 over 3. Now, where's tan negative? Tan is negative in the second and the fourth quadrants. Now, what we do is we take the tan inverse, and in radians that would be 0.3218 we take the tan inverse of the positive of this angle. Why the positive? Because that will give you the related acute angle, and from that we can calculate what the angle is from standard position. For example, for quadrant 2, we would take pi, which is this line right here, and subtract 0.3218 to find the angle from standard position. For this angle, we would take 2 pi minus 0.3218 to calculate the angle from standard position to this line. So we do the following. Now, if you want to calculate it in degrees, you can, and then calculate the angle in degrees before you convert it to radians. That's acceptable too. It would be 18.4349 degrees, so 360 minus that degrees, or 180 minus that degrees. Bottom line is, these are the radians that you're going to find because the question says find the value of theta between 0 and 2 pi. So that means these are our 2 radian measures of tan theta of negative 1 over 3 for this quadrant and for this quadrant. All right, let's moving on forwards. Example number 2, solving 2 sine theta cos theta is equal to cos 2 theta on the interval from 0 to 2 pi. So we're not trying to prove this, folks. What we're trying to do is solve for this. What that means now is that we need to solve for theta. How do we do that when we have a double angle? Well, what's important to note that this side is actually equal to sine 2 theta, and that's because of the double angle formula rule. Double angle formula says that this side must be sine 2 theta. The other side must be cos 2 theta. So what we're going to do here is we have to look at this and now say, look here. Originally we had two trig ratios on one side and 1 on the other, and now we've done down to 1 on each side. How can we continue to get it so that we have 1 to solve for? Well, if I divide both of these by cos 2 theta as such, what will that give us on this side? Hopefully you'll see that that will give us a 1. And what will that give us on this side? Hopefully you're looking at it and see that the quotient identity is listed there, and we will have tan 2 theta is equal to 1 because of the quotient identity. Well, now we can solve for 2 tan. Tan inverse of 1 is going to be, okay, now this is a recap of why we can do this, all right? So I just want to show you something over here, specifically over here, looking at this, okay? And we're just going to go back a step just so that we can see that step. Sorry, folks. 1 second. All right, so looking here, I want you to see right over here, I want you to see this. Normally, when we see 2 over x is equal to 1, what we would do is multiply the x to the other side, so we get x equals 2. That essentially is what I had over here. And what I'm doing is I'm actually working backwards. I'm trying to get 1 on this side so that I would divide both sides by x. And that's how I get 1 is equal to 2 over x. In this case, what I did is I tried to make my 1 this way, so I get 1 is equal to sine over cos. What that gives me is our tangent ratio. So when is tan equal to a positive value? That would be in the first and in the third quadrant. And that value of 1 will have to be pi over 4. Okay, and now looking here, you would probably say, okay, so it's pi over 4 and 5 pi over 4 are my only values. Therefore, these are my values over here. And normally I would say, maybe you're right, but wait a minute, I want you to go back a second. We calculated these values based on theta. Well, it's not theta we're looking at, folks. It's 2 theta. Our domain is listed for theta. We need the domain for 2 theta. What is the domain for 2 theta? The domain for 2 theta is actually goes from 0 to 4 pi. Why? Because theta doubled is 2 theta. 2 theta is double both sides, which gives you from 0 to 4 pi. So we need actually all of the possible values from 0 to 4 pi. 0 to 4 pi goes once around, that is 2 pi, 3 pi to go here, 4 pi to go here. So it's like going around in a circle twice to go 4 pi. That means I need this arm appears itself twice, as does this arm, because following the finger goes around. Okay, so once here, twice here, and we go around again, 3 times here, and 4 times here. So really, what are the extra values we're looking at? Well, they will be 9 pi over 4 and 13 pi over 4, which then when you divide by 2 will equal these values. Again, one more time, why is that? Remember that I'm going around again for the second time, so this arm is going to be 9 pi over 4, 2 pi, plus pi over 4, and then going around this way, it's going to be 3 pi plus pi over 4, which is 13 pi over 4. Divide everything by 2, and these are their values for theta. These are all the possible values that run for theta, that runs between 0 and 2 pi, that covers this information. All right then, on to another one. Example number 3 from the textbook. So we've just got the question from the textbook talking about the high tide in Matthews Cove. The high tide in Matthews Cove, New Brunswick is at midnight. The water level at high tide is 7.5 meters. The depth d meters of the water in the cove at the time, t hours, is modeled by this equation. Jenny is planning a day trip to the cove tomorrow, but the water needs to be at least 2 meters deep for her to maneuver her sailboat safely. How can Jenny determine the times when it will be safe for her to sail into the Matthews Cove? So, we have a depth, and we set the depth equal to 2. We want to know at what times will it reach 2 meters. So we set it equal to 2, and we solve for pi over 6. We solve for t by slowly moving things over. 2 minus 4 is negative 2. Then we divide by 3.5. And finally, we take the cos inverse, and that's pi over 6t. If you're working in degrees, convert the pi over 6 to 30 degrees. These are going to be your 2 answers right here, folks. How do we get these 2 answers? Well, when you take the cos inverse of the negative, you remember that cos is negative in 2 quadrants. That would be in the second and third quadrants. So knowing that, we have 2 values of degrees, okay? And these are 2 values in degrees because these are our answers here for this and this. We find the related acute angle, and this will be pi minus the related acute angle, and this would be pi plus the related acute angle, and then we take those values and divide it by 30 degrees. And that will end up with, don't forget we have to convert it to radians, and that's what we're looking at. So we've got a graph here, but rather than looking at this graph, we'll look at a larger version of the graph in order to make this sense of this. So we're going to look at it on the next page. So moving forwards to the next page. All right, so we need to have this. So how do we find out what the maximum and minimum are? Well, the maximum is going to be the equation of the axis plus the amplitude, which is 7.5. The lowest is going to be the equation of the axis minus the amplitude, which is 0.5. Now, this graph reaches the highest, it starts at the highest at the y-axis because of the following. Let's look at the equation, and so I can explain this. So, we know it's going to be the cosine graph. We know there's no horizontal translation, so that means the cosine graph begins on the y-axis at either the highest point or the lowest point, because the cosine graph normally begins at either the highest or the lowest depending on the sign. We're going to start with the highest because the cosine graph is positive. So again, the cosine graph will either look like this or look like this, depending, again, whether it is the highest point it starts with or the lowest point it starts with. In our case, it starts with the highest point because the cosine graph is positive. So, knowing that, we're going to start with 7.5, and this graph has some end point. For example, the period. Before it starts repeating itself, we have to calculate the period. The period is always 2 pi divided by the k value. 2 pi divided by the k value will result in the number 12. So what does that mean? Well, this graph will end back at 12. So it starts at the top, goes down, comes back up to 12. And guess what? It's going to do it again, because what we need to do is find out when the water level reaches 2. 2 is the water level we need, because the boat is safe when the water level is higher. The boat is not safe when the water level is lower. So, looking at this graph, at which point is the water levels the highest? We found out that it's at 4:10 p.m. How did we get 4:10 p.m.? Well, remember that it was 4.1617. That's what's listed here. So 4 hours and 0.1617 of an hour. So this decimal part, 0.1617, you have to multiply that by 60. When you multiply by 60, you find out it's about 10 minutes. Okay? And then we have to calculate the other part, 7.8383. 7.8383 will be this value, and that will be at 7:51, roughly, 7:50, 7:51. The goal here, though, is the fact that you can find between these two times, this is when the water level reaches 2. So at this time it's at 2, and at this time it's at 2. So what happens between these times is the key question. Remember, this is about water level. So when we look at the coloring of this, if we look at the comparison, we can see that the water levels is higher before 4:10 in the morning or after 7:50 in the morning and back again before a certain time over here. Does anyone know what that time is? Hopefully you're remembering about the domain, that period. The period is 12. That means that every 12 hours, these particular times repeat themselves. So it's like the tides rolling in and out. So this time, 4:10 repeats itself out again at 16:10. 16:10 is 4:10 in the afternoon. So you would say that it is safe for Peggy to go into the cove at between 7:51 in the morning to 4:10 in the afternoon, because this is when the water levels are above 2 meters. So again, from 7:50 to 4:10. All right, that's the end of the video, folks. Have a great day.